You have notes in front of you. You need to memorize these formulas and know these formulas. If you don't want to memorize the tangent formula, if you know that it's sine over cosine, then you can just use sine over cosine. That'll work too. So you need to know these. You also need to know your special triangles. These are right triangles. The pi over 6, I'm talking about that angle. This pi over 3, I'm talking about that angle. That's a right angle. And the pi over 4, I'm talking about that angle. Okay? So make sure you know the angle is in degrees and radians. So you need to know these special triangles too. So find the exact value of sine of 45 degrees minus 30 degrees. So you would look at your formulas. And here we have the sine of alpha minus beta. Well, here I have 45 minus 30. 45 is alpha, beta is 30. So we use the above formula. So the sine of 45 minus 30 is equal to the sine of 45 cosine of 30 minus, it's minus not plus, minus the sine of 30 cosine of 45. If you need to, this is what I do a lot of times, is I'll write the triangles 1, 2, radical 3, and 1, 1, radical 2. Gives me a visual to look at. Sine of 45 is 1 over radical 2. Cosine of 30, look at your 30, is radical 3 over 2. Minus sine of 30, look at your 30, is 1 over 2. Cosine of 45, 1 over radical 2. And if you want, you could write these as radical 2 over 2 right away. It does not matter. So when you multiply this, 1 times radical 3 is radical 3. And then bottom you have 2 radical 2. And here I have 1 over 2 radical 2. Write as 1 fraction. Get rid of the radical by multiplying top and bottom by radical 2. When you do that, radical 2 times radical 3 is radical 6. Radical 2 times 1 is minus radical 2. Here you have radical 2 times radical 2, which is 2, times 2, which is 4. There's your answer. You're done. Next, find the exact value of 285, the cosine of that. When you see a number that has a 5 in the end, remember that you will use 45 plus or minus some number, or minus 45 somewhere in it. So I could use like 240 plus 45, because 45 degree triangle is one that you know. And 240 is actually one you know too. Here's 180, 240 gives you a 60 degree reference angle there. So that gives you 1, 2, radical 3. So you could do that if you wanted. You could do 135 plus 100 and, hold on, 50, not 40, 150. And that gives you a 45 degree reference angle. And 150 gives you a 30 degree reference angle. Those triangles. And then you just use the formulas. There's lots of ones. You can do some subtraction, okay? So you just pick 2 angles, either added or subtracted, that equal 285. So that's what I said here. Here are a couple of examples, but there's lots of them. Okay? I used 150 plus 135. So let me redraw this, because I'm going to erase these pictures over here. So 150 degrees, that's 150 degrees, 30 degree reference angle, 1, 2, radical 3. 135 gives me a 45 degree reference angle. That's 135 degrees. Okay? So there are my pictures, so you have pictures. And then it's really easy to do sine, cosine. So that's equal to the cosine of 150, cosine of 135, minus the sine of 150, sine of 135. Look at my 150. Cosine is negative radical 3 over 2. So negative radical 3 over 2. Cosine of 135 is negative 1 over radical 2. minus sine of 150, it's 1 over 2. Sine of 135 is 1 over radical 2. Negative times a negative will become a positive. So I have radical 3 over 2 radical 2. Here I have 1 over 2 radical 2. If you want, you can write it as one fraction. Get the radical out of the bottom by multiplying top and bottom by radical 2 over radical 2. Radical 2 times radical 3 is radical 6. 1 times radical 2 is radical 2. Radical 2 times radical 2 is 2 times 2 is 4. So there's my equation. And I'm done. Next. Cosecant. I didn't give you a formula for cosecant, but I did give you a sine formula, and you know that the cosecant and sine are reciprocals. So I could just find the sine of pi over 4 minus pi over 3. I could just use the difference formula. Okay? You can do pi over 4 minus pi over 3. Okay? So the sine of pi over 4, cosine of pi over 3, minus sine of pi over 3, cosine of pi over 4. Let me draw my pictures. 1, 2, radical 3. This is pi over 3 angle, that angle right there. Okay? Pi over 4, 1, 1, radical 2, that's a pi over 4 angle. So now I have the pictures to look at, so it makes it even easier. The sine of pi over 4, that's my second triangle, 1 over radical 2. Cosine of pi over 3, 1 over 2. Minus the sine of pi over 3, top triangles, radical 3 over 2. Cosine of pi over 4 is 1 over radical 2. Multiply it out, simplify it. I have one fraction, but remember that's the sine. I don't want sine. I want cosecant. So cosecant is the reciprocal, so I can just flip it if you want. If you want to see the math behind it, you would do 1 over the fraction, numerator divided by denominator, same thing as numerator times the reciprocal of the denominator. You don't need to write all this out if you know already just to flip it. Now let's get the radical out of the bottom, so I'd multiply top and bottom by the conjugate of the denominator, so 1 plus radical 3 on top and bottom. And let's keep multiplying. 2 radical 2 plus 2 radical 6 on the top. Over. When I FOIL it, I have 1. Outer and inner cancel out. Minus 3. So 1 minus 3 on the bottom. 1 minus 3 is negative 2 on the bottom. And if you want, you can think of this right here as, I'll write it over here, 2 radical 2 over negative 2 plus 2 radical 6 over negative 2. So you end up with negative radical 2 minus radical 6. So there's your final answer. Next one, example 4. Find the exact value of 11 pi over 12. Well, you're thinking to yourself, pi's over 12. They only gave me pi over 3 and pi over 6s and pi over 4s, pi over 2s, no pi over 12s. So we can think of those angles, pi over 6, as something over 12, which is 2 pi over 12. And if you write it like that, it'll be a lot easier. We can think of pi over 4 as 3 pi over 12. We can think of pi over 3 as 4 pi over 12. But really, all you need to focus on are these two angles. Because if I take those two angles and any multiple of that, I will have all the pi over 3s. Because 2 of these angles equal 1 of those. Okay? So now, I want, in my mind, I'm thinking to myself, 2 pi over 12 times some number plus 3 pi over 12 times some number. I want that to equal 11 pi over 12. What I usually do is I look and say, okay, 11 on top, odd number. So that means I want an odd number of the 3 pi's over 12. I want either one of those to get 3 pi over 12, or 3 of them to get 9 pi over 12. Okay? Or, I don't care, 5 of them to get 15 pi over 12, and then I would do a subtraction. Okay? So I just want to see what combinations. There are infinite numbers. So you might do it one way, I might do it another way, your friend might do it another way. Okay? So just know that there's multiple right answers. Okay? So what I used is I used just one of the 3 pi's over 12, and I used 4. I just used one of these and 4 of those, because 4 times 2 is 8, plus 3 is 11. That's not the only way you can do it though, okay? Like I said, I could have used 3 of these, 9, and just used one of those. And that would have worked too. So now that I have the 2 angles I want to use, remember this is really just pi over, 3 goes into 12 4 times, so this is really just pi over 4. And this right here, 8 and 12, 4 goes in that, so that's really 2 pi over 3. Okay, so that's really what they are. And here, let me draw pictures. Remember, 3 pi over 12 is really pi over 4. This does cancel out. And then this one really is 4 goes into 8 2 times, 4 goes into 12 3 times. So the 2 angles that I have are 45-degree triangle, or pi over 4. And my second one, 2 pi over 3, that's 2 pi over 3. Pi over 3 is 60 degrees, 1, 2, radical 3. So there are my 2 triangles if you want to draw them out. I think it really does help. And now use the formula, the tangent formula. Let's remember that the sum of tangents is equal to the tangent of my first one plus the tangent of my second one, divided by, whatever it is, 1 minus the tangent of my first one, tangent of my second one. Okay? So remember, that was this one right here. Okay? So tangent of 3 pi over 12 is 1. Tangent of 8 pi over 12 is radical 3 over negative 1, which is negative radical 3. You could just write it as negative radical 3 if you want. Over 1 minus 1 times negative radical 3. Just write it that way if you want. So here's what I have. 1 minus radical 3 on the top. And I have 1 plus radical 3 on the bottom, because minus a negative becomes positive. Multiply top and bottom by the conjugate, which is 1 minus radical 3. And the proper way really to do it is that's what we're doing. Okay? So when I multiply the top, I get 1 minus 2 radical 3 plus 3. Put that somewhere. I guess I rewrote it. That's what I said right there. I have 1 minus 2 radical 3 plus 3. On the bottom, I have 1, outer and inner cancel out, minus 3. 1 plus 3 is 4, so I have 4 minus 2 radical 3. 1 minus 3 is negative 2. 4 over negative 2 is negative 2. This negative becomes positive then. 2's cancel out, radical 3. Remember that I cannot just cancel those 2's out, that negative 2 belongs to both of those terms. So if you want to cancel out, you have to write it like this first, and then cancel out, okay? That's why they cancel negative 2 and cancel. So that's why you have negative 2 plus radical, this is 3, hard to read, radical 3. And I'd probably write it as radical 3 minus 2. Sometimes when you write a negative in front, you lose it. Next example. You could have used a different one, like I said, 11 pi over 12. So I could have done 11 pi over 12. That's using 3 of those, 3 of the Remember the 3 pi ones? And one of the pi ones, okay? So remember that this really is 3 pi, because 3 goes into that 9 3 times, 3 goes into that 4 times. The second one really is pi over 6. Get 2 of those. And if you were going to draw them out, 3/4 pi, 1/4, 2/4, 3/4 pi, 1 1 radical 2, pi over 6, 1 2 radical 3. So there are my triangles, and you could just use the same thing right there. Tangent of 9 pi over 12 is -1. Tangent of pi over 6 is 1 over radical 3. And then on the bottom, got my 1 minus, I have 1 minus. Those multiply. Okay. If you want, you could write it like this. It's not the only thing to do. I could also multiply top and bottom by radical 3, and that would work too. Okay. So from here, algebraically, there are many things you could do. I just gave everything a common denominator of 3. You don't have to do that. You can multiply stuff by radical 3. Actually, I'm going to do that instead. So don't forget this. If I take top and bottom and multiply by radical 3, I have negative radical 3 plus 1. Okay. And here I have radical 3 plus 1. Okay, so I have 1 minus radical 3 over 1 plus radical 3. And then, oops, I would say equal, conjugate. And then I have 1 minus 2 radical 3 minus 3. On the bottom I have 1 minus 3. I have here, there's a mistake somewhere. Where's my mistake? Say plus, sorry, when I foiled it. 1 outer and inner is minus. A negative times a negative is positive. So I have 4 minus 2 radical 3 over negative 2. And that's where I was in the last spot. See? 4 minus 2 radical 3 over negative 2. So you see you get the same thing.